Hey everyone, and welcome to this explainer. Today, we are going to dive deep into a component that is absolutely guaranteed to elevate your B4X and B4A application layouts. We're taking a really granular look at the B4XDaisyToggle. We're going to unpack the actual source code, look at the precise UI renderings, and show you exactly how this component hands you total control over your app's switches. So let's jump right in.
Right, so think about the last settings menu you built. You've all been there, right? You end up relying on those standard, rigid OS toggles that, let's be honest, make your app look like it's stuck in 2012. But modern user experience demands way more than that. It demands nuance, it demands theme consistency, and honestly, sometimes a simple yes or no just doesn't accurately reflect the data state your application is actually in. Those standard toggles, they just fall incredibly short of what we need today. So here is our roadmap for today. We'll start by going beyond yes and no. Then we'll explore color variants, dive into sizes and label alignments, and finally we'll wrap up by unleashing some custom styling.
All right, Section 1, beyond yes and no, the indeterminate state. Okay, so the absolute crucial point here is understanding the foundational behavior of this toggle. What exactly happens when a setting isn't quite on, but it's not off either? Well, looking under the hood at the source code, we see a specific Boolean property called indeterminate. When you set this to true using this setIndeterminate API, the component actually forces the standard unchecked state to false. This is a brilliant way to handle complex logic. Just imagine a select all toggle where only, say, a few of the child items are selected. It's not fully true, it's not fully false, it's indeterminate. Picture a standard base toggle. You've got your dark, filled-in checked state, and your light, unchecked state. But right there in the middle, you have the indeterminate toggle. It's perfectly grayed out, visually communicating that undefined mixed state to the user without a shadow of a doubt. And what's really cool is the clean textless versions. The B4XDaisyToggle actually dynamically estimates its preferred width and height. So if you don't pass a text string to it, it just perfectly wraps the knob and track into this super tight standalone visual element. Moving right along to Section 2, exploring color variants and setting the theme. Now, let's shift gears a bit from the core logic to the aesthetics. The B4XDaisyToggle exposes these amazing designer properties that let you match literally any app theme instantly. Right inside the B4X designer, the variant property accepts a specific list of 9 semantic string values. You've got none, neutral, primary, secondary, accent, info, success, warning, and error. Under the hood, the component calls an update theme routine, which resolves these semantic tokens against your app's global styling. It literally translates those strings directly into actual hex colors. And the result is stunning. These semantic string properties instantly render into bright, pixel-perfect UI elements. You get a vibrant purple for a primary toggle, a really bright blue for the accent, a nice solid green for success, all the way down to a stark, unmissable red for the error toggle. By simply changing one tiny string in the B4X designer, or, programmatically calling set variant, you completely transform the emotional context of that switch. It's just an incredibly efficient way to build forms that visually communicate with the user. Okay, Section 3, sizes and alignments, perfecting the layout. Let's talk physical dimensions, because a great UI component absolutely has to adapt to fit real-world app layouts. Dive into the source code and you'll find dedicated routines like resolve toggle size dip and resolve text size points. These routines translate string values into precise device-independent pixels and text sizes. For example, the XS, or extra small, toggle renders at a tiny 16 dip height with a 10-point font. On the completely opposite end, XL scales all the way up to a massive 32 dip height with a 16-point font. And the best part? The internal padding logic scales dynamically with these sizes, so everything stays perfectly proportioned. When you contrast that tiny extra small toggle right next to the massive extra large one, you really see the component's dynamic range. It scales up without losing any resolution or padding integrity whatsoever. The knob remains perfectly circular, the track border scales up just right, and the distance between the toggle itself and the label remains totally readable. This means whether you're trying to pack a dense data entry grid or you're building a highly accessible menu for visually impaired users, this one single component handles the entire spectrum. It's a real game changer. Now, another absolutely crucial layout feature is the label alignment. The position property dictates exactly where the label sits relative to the toggle switch. Position start drops the toggle in first, leaving the label on the right. Position End flips it, placing the label first with the toggle trailing off on the right side. So when you're building out flexible, varied list views, especially for right-to-left UI layouts or even those standard iOS-style settings menus where the text is flush left and the switch is pinned to the far right edge, this one single property does all of the heavy lifting for you.
And finally, Section 4, Unleashing Custom Styling, Breaking the Rules.
Okay, this section is specially dedicated to the UI designers out there who need absolute pixel and color control. Because what if those 9 semantic variants we talked about earlier just aren't enough? Well, the B4XDToggle API exposes explicit override methods. You can call checked background color, checked border color, and checked text color. Plus, you get standard overrides for the unchecked state too. Setting these completely bypasses the built-in token resolution, allowing you to inject totally custom integer color values directly into the drawing routine. So you can supervise everything perfectly from every scenario, both fully and software native.
When you do this, you are completely breaking the rules of standard toggles. You can create this beautiful custom styling where, for instance, a deep indigo unchecked track seamlessly transitions into a bright orange checked track. You explicitly control the border colors, the background colors, the whole shebang. You aren't just limited to a single color fading in and out. You can actually define totally contrasting states, which makes your UI incredibly distinct and allows you to brand it exactly to your corporate identity.
So we've really covered some ground today. We explored the complex logic behind the indeterminate state, we cycled through that instant semantic theming, analyzed the rigid mathematical scaling of the different sizes, and finally unlocked total color override control. The B4XDaisyToggle is clearly way more than just a simple on and off switch. It is a highly adaptable UI workhorse. So the question I want to leave you with today is this. With unlimited states, sizes, and colors now sitting right at your fingertips, what will you build next? Open up your B4X environment, drop in a DaisyToggle, and just start experimenting. Thanks so much for joining me on this explainer, and happy coding.